Hey everyone, welcome back to my YouTube channel, and today I really just want to cover things that you should know if you want to stand out as a biomedical engineer, or where do you even start if you want to get into the field. So I want to build upon a couple of the previous videos that I already spent some time discussing what types of career pathways you can do with biomedical engineering, some of my experiences briefly, and some of my research work, so you have hopefully a little bit of an idea as to what biomedical engineering already is and a little bit about my background specifically. So, biomedical engineering sounds very exciting, but what does it really look like in the real world? I mean, what we've covered on the day to day is that biomedical engineering can do a realm of different things depending on the field you go on. So, of course, take everything that I say as a guide, and not everyone's story is going to be the same as a biomedical engineer because there's so many different pathways that you can really just go into. But on the actual day to day, a biomedical engineer is sitting there doing a lot of design thinking. If you're especially going to sit there and design implants, you're going to design some sort of system, some equipment, something that is related to patients, the healthcare, this sort of setting. Now, of course, this can stretch beyond just equipment and devices, right? You can be formulating some drugs, you can be even designing just a process. That is all part of it when it comes in the realm of biomedical engineering, which is why I said take everything that I say with a little bit of a grain of salt because everyone's pathway is so different. But practically speaking, you're doing a lot of design thinking. And for those of you who don't know what design thinking is, it is literally the process where you think about your needs versus your wants, but not for yourself, for the customer, the patients, whoever it is you are trying to solve the problem for. So you are doing a lot of iterative process and thinking where you're saying, here's what I need. These are the requirements of my system, and this is what my constraints are. This is what I can't do. These are some of my restrictions. Now, how do I build a solution that will still have what I need in the system, but I won't exceed past my constraints? But then I can also achieve what the patient wants, right? Or what the client wants. I want to build something that's desirable and it's actually going to be useful for a human. Maybe it's something that's getting put into a hospital. So at that point, you're really worried about nurses and doctors interacting with it. Maybe it's something like a continuous blood glucose monitor. Well, now you're dealing with a patient. How's the patient going to interface with that device? So as you go through this process and this thinking, you're coming down with solutions on the day-to-day, right? And depending on whatever team you're on, you're doing different parts of this design thinking. Once you create the solution, you also have to make sure you test it before you go and send it directly to a patient. So there are teams on the day-to-day that literally sit there and do verification and validation testing. So you are taking some components of that system and you're going to test it and actually see, is it achieving the needs that I told it that I wanted to achieve? Is it actually getting to those requirements? And you'll probably have some quantifiable numbers that you want to achieve, some metrics. And so it's sort of a loop as to what you're doing as an engineer. Is you're going through this design process, creating these solutions for whoever it is, and you're going to continuously loop because you're probably going to find some error and you're like, wait, I need to fix this, so let me go back into earlier in the process and figure out, how do I solve this problem? So on the day-to-day, again, like I said, depending on what team you're in, your day-to-day is going to look different. You could be doing a lot of testing. You could also be doing a lot of R&D early in the stage, doing a lot of research development. Or maybe you're just not that tech savvy and you just want to do something else. You want to do something on the computational side where you can leverage your skills. Or maybe you just want to do project management. Maybe you just want to know the overall process and you're really good at big picture thinking. You don't want to get too involved in the chemistry. You don't want to get too involved in the bio side of it and the physics. You know a little bit, you know enough, but you're really good at being a people manager. So maybe you want to showcase some of your skills, but more from a management perspective. So the reason I'm saying all of these things in terms of what does a biomedical do on a day-to-day is because there's so many different opportunities that you can go into if you are truly going into biomedical engineering in this field. And because of that, a lot of people are afraid that, hey, I haven't taken chemistry for a really long time. I'm not taking it in college. The last time I took it is in high school. This is actually true for me. So true story, I actually took AP chemistry in high school, and this is about junior year of high school. And I literally never took a chemistry class in college because I skipped out with AP credits. I took the AP exam and I didn't need to take it again. So a lot of my chemistry knowledge is just applied in the field knowledge that I've gained from the jobs that I've been at and things that I've learned and integrated with other activities that I've done throughout my research and career pathway. So do not be afraid if you're not taking a science course, because maybe you're not as strong or you're not as familiar, you don't feel too comfortable going in that pathway. You can go to different routes. You don't need maybe as much chemistry in the verification process. Maybe you need more of that mechanical mind to do mechanical testing, compression testing. And when I say compression testing, if you guys aren't aware, commonly in a lot of medical device companies, you'll have like some sort of device and you'll put it under something where you'll have a force thing and it's coming and crushing down that thing to actually detect the force. How much can that force be withstood on that device that you're testing? So maybe you're going to go more into the mechanical side. So my point is, you don't need to have all of the skills. Biomed is a very broad area, and maybe there are some areas of it you're a little bit weaker, and maybe some areas that you're a bit stronger, but you can use that to your advantage to then cultivate a pathway that allows you to excel in that area. And you do not need to do everything. You can really find your niche, even within biomedical engineering being a niche itself. Now, the other tidbit I want to say is, you're probably asking, well, then what skills do I need to stand out, right? On one hand, I'm saying, it's okay if you don't have these skills. On the other hand, you're like, you still need some skills. What are they? So, if I had to bet on a skill that separates average BMEs from great ones, what do I think it would be? What do you think it would be? Specifically, it's really just soft skills at the end of the day. I think technical skills will come with the job or whatever career pathway you're in. And the reason I'm saying soft skills is because soft skills is very universal. How do you talk to people? How do you manage things? How do you become a leader? These are all important things. How do you be a people person at work? Make sure you really focus on gaining that confidence when you're in college or in your career and you're trying to grow with yourself. You're trying to learn more about yourself so you can really strengthen these soft skills, especially communication. I think that is the biggest thing people lack. People just have something, they just do it. But in reality, you're always working with a team, so you want to make sure you are able to stand out by having lots of communication skills and you're able to get your message across clearly to other teams to be able to effectively achieve a common goal. At the end of the day, you're not working alone. There's a number of stakeholders involved, whether it's your team or external people you're selling a product to. So I would say make sure you really take your experiences to build on your soft skills. Now, the secondary portion to this question about skills that separates average BMEs are going to be your technical skills. And you should have a good foundational knowledge of these technical skills, right? Have familiarity in different things, especially coding, because now everything is being automated. So if you're getting into the field, do not be afraid that you need to know everything. Know a bit of everything, but you don't need to be an expert in everything. Maybe you'll find your focus area based on the exploration across all of these different technical skills. And that's what you're going to choose to focus in, but you're still going to have that knowledge in the other areas. So, like for me, I knew that my strength wasn't biology, and it wasn't really chemistry because I didn't take chemistry since high school. But now I'm in pharma, and all I'm really doing is a lot of chemistry. So I focused my skills in other areas that I was really, really strong in, things I was able to pick up very easily, especially the mechanical side. And what I learned is I focused all my research in that area. And for the chemistry and biology side, I really needed to see things to understand what the heck is going on. And how did I pick that up? Jobs, internships, experiences. Every job is going to be so different, including every project you do. Now, when you go to a job in the field, whether it's for an internship or a full-time position, most of the time you're going to learn the technical skills they need. Every job is so specific, so it's kind of hard to say you're going to need this skill. Unless it's coding, where it's universal, a little bit more universal, where you need to learn a language. Then you need to learn a language. But for the most part, if you're a scientist and an engineer, you're going to need very specific skills for that job. And a lot of them are taught on the job. So just make sure you're good at picking things up on the fly and learning and being motivated, because that's going to be a key thing. Show your motivation, show your enthusiasm. Make sure you are a person that enjoys learning, because the learning curve for BME is pretty high. So you are going to have to learn a lot of things, and they're going to be different things. But once you learn that on the job, then you can start to apply them and you'll have those technical skills. So build off of what you have and leverage your jobs and your internships and your experiences to build more technical skills that you need for that specific position in that time and place that you're at. And that is going to evolve as you go through more jobs. Your skills are going to evolve, your experiences are going to evolve, and then you're going to ultimately, eventually, hopefully, find your niche in that career area. So another thing that you may be concerned about, especially going into biomed, is how do you build experiences while you're still in school? And do recruiters really just look at GPA? What do they actually care about? So here's the thing. GPA is great for your internships and probably your first job. But beyond that, it doesn't really matter. You need to gain experiences. Obviously, internships are going to be the best way to do that. But if you can't get a hold of internships in this economy, because it is very, very difficult nowadays, make sure you try to be a self-starter. Even if you're in high school, you can start doing this. You can outreach to different colleges right now to actually build some skills. It's okay if you don't have the skills. Just say you're interested in X, Y, and Z that maybe a professor has a paper on, and you can do a lot of research, right? About, okay, we have this professor at this university and they're working on this. Reach out to them, email them, they'll have a contact information. Just say you're interested in learning more about it. Do you have any opportunities for volunteering over the summer or over the school year where I can just shadow and learn more about what you do so I can gain a better understanding of this field and decide if this is the area I want to be in? I've told a lot of people that, and they've actually been able to get internships. I actually did one myself before even getting into college. I did one at a college while I was still in high school over the summer. And that really helped me understand what the field is about from a more technical perspective. Now, things might be going over your head when you're learning about these things from college graduates or professors, but that is perfectly okay. Exposure is the most important thing at this time. So if you can't get an internship, make sure you start reaching out to people to see if you can get even unpaid volunteering experiences. Maybe you can help out in certain ways. Maybe you have skills and new perspectives that graduate students don't. Maybe we're all just thinking about something in one way because that's how we're trained to do it from college. But maybe you have a whole different perspective as a high schooler or even middle schooler, right? So it doesn't matter. Other things you can do. Maybe that's not working out. You have emailed so many professors. Still can't get an unpaid internship. Still can't get a paid internship. Can't get any shadowing anywhere. This is where you're going to put on your research hat. If you like research or if you like business, right? Think of problems that are in your immediate area. They don't have to be big. They can be small. Think of health issues that arise. Just do a bunch of research. See what's going on and try to build a solution of your own. And this is going to be a little bit difficult. Maybe you find a group of friends to do this with. See if you can build out that solution. And it's okay if something already exists. Maybe you just want to make it better. Maybe use that as your starting ground. But take that project and lead that project. Take initiative and build maybe a mini portfolio. Maybe you're just doing a bunch of projects that summer to build the experience. Make sure you're writing exactly what you're doing on each of these projects, and you're creating folders and you're creating portfolios, because then what you can do is you can transfer all of these projects, whether they're independent or group-based, and you can put them on a resume, in addition to any school projects that you already do. So this is going to really help differentiate you, because if you're thinking about it, if you're in the same school and you're all going for internships or jobs, Maybe everyone already has school projects that you've all mutually and commonly done with each other on their resume. But then everyone's resume kind of looks the same because everyone has the same experience. How do you differentiate yourself? The unique experiences that you get is what's going to differentiate yourself. Your unique projects, things you've led, internships you've done. It's not just about GPA. It's really about the clubs, the side projects, things that you're involved in that are going to help you get those skills, especially soft skills, as well as the technical skills. And lastly, involve yourself in clubs, right? If you're not already in clubs, there are different societies, professional societies, there are different organizations that you can take a part of to really understand more about the field. You just literally by reaching out to people, maybe on LinkedIn or people in the field already, to talk about what do you do? What's your experience? That's going to help you learn a lot as well. So the main point of this video really is life is tough, and biomedical engineering is a very big field that you can do whatever you really want to do. It is big enough to go in whatever area, but it's also small enough for you to focus in whatever area you want to go into. You might be afraid that you don't have this skill or that skill, but remember that you can build your own career path. You don't need every single skill. That is the beauty of it. It's okay if you haven't touched chemistry in a really long time. It's okay if you haven't touched physics or you're not that good in physics. There are other areas of biomedical engineering that you can build off of. Now, maybe you hated biology like I used to hate, and your love for biology will grow. Allow yourself to think of the bigger picture. What am I actually solving? I'm actually helping people. And that's what I really care about. And if you really care about that, then you will find a way to figure out your love for biology that will allow you to leverage that and help the people. And it's not really just about learning about cellular respiration or photosynthesis. It's about using biology in a way that is applicable to what you are trying to solve. And I think if you start changing your mindset to that, it's not just about courses that you take. That stuff is just there for foundational knowledge. It's about, at the end of the day, what are you solving? Do I have a little bit of every knowledge that I can maybe piece things together and maybe pick up some other things from other people to solve it? If you have the motivation to answer this question, I think you're in the right place for biomedical engineering. Are you motivated to help people in whatever capacity you can, especially patients around the world? If your answer to that is yes, you're in the right area. If your answer to that is maybe, but I find myself doing engineering in other ways too, maybe mechanical engineering is more for you. And there are different types of engineering that you can go into. And maybe that's just what your niche is. And I really would like to cover the differences between biomed as well as mechanical engineering and what kind of made me choose biomedical over mechanical in a later episode or a later video. But for now, I just want to leave you with that thought. Are you ready to help patients? And if your answer is yes, stay tuned for more videos. If your answer is no, still stay tuned because I'm going to cover another video that maybe will help open up your eyes and perspectives to figuring out what is the correct career pathway. So with that, thanks for listening and watching this video. I'll see you guys next time.